So today we are going to start new chapter number 5, that is Introduction to Euclid's Geometry. So about the Euclid geometry, we are going to just learn some basic things. That is why it is written introduction only. So first of all, I just want to tell you this Euclid means that is one of the mathematician, and he have got some rules in mathematics. So about that we are just going to discuss. So first of all, page number 81. Everyone, you need to look at page 81, and you will see there 7 point. Page number 81, 7 point. So these are the Euclid axiom. It is already written here. Euclid axioms are given here. So this 7 point you need to read first with meaning. You have to understand this one. You have to read. You just go through up to here 7 point. Then after this 7 point, next page you will just turn. Then you will see again another 5 point. Euclid 5 postulate. Postulate number 1. Then postulate number 2. Postulate number 3. Postulate number 4. And postulate number 5. So 7 axiom and 5 postulate. Altogether 7 plus 5 is 12 point you need to know first. And among that 12 point also, the last postulate is very important. You read carefully this one. Then after knowing this all, then only we can go to the exercise. So first of all you learn that axiom, and after knowing that axiom you will be able to answer this question. Like question number 1, true or false. It is based on that axiom and postulate. So you will be doing yourself this one. Again, question number 2, that is give the definition. Like parallel line, perpendicular line, line segment, radius of a circle, square. This also you will write the definition yourself. You have started learning about this definition from class 6 and 7 only, so you will be able to know. Then question number 3, consider 2 postulates given below. So this is also you will be doing. You will just read and you need to consider from which postulate these 2 statements belongs to. So that you just have to tell. Then in the next page, so from here we are going to start now. Page number 86, question number 4. So from here we will be doing. Okay, so I will be doing question number 4. Number 5.1. Question number 4. So let me read the question first. If a point C lies between the point A and B such that AC equals to BC, then prove that AC equals to half of AB. Explain by drawing the figure. So we need to draw the figure first. You will then after this, C lies between A and B, means here it will be C now. And such that given AC is equals to BC. According to your question, this side and this side they are equal. Okay. AC and BC. This one and this one they are given equal. And we are going to prove is AC equals to half of AB. This we are going to solve. This should be our answer. So they ask to explain by drawing the diagram. So diagram is this one. Then I will just write the solution here with explanation. That is, now in your solution, first let us write the given. What is given? AC equals to BC. So given is this one. Now we will do proof. Okay, so proof is, so how we are going to prove is, Now, first of all, AC plus BC equals to, look, AC and BC, if you add both together, it will become AB. You can see in the diagram, so that value is equals to AB. Now, in the next step, what you can do is AC plus AC equals to AB. See, instead of BC, I have written again AC because it is given here. AC is equals to BC, means they are equal. So instead of BC, we can use AC. Now, AC plus AC will become 2 AC. That is equals to AB. Now you will get AC is equals to half of AB, and this is the answer. See, this 2 and it will go this side, it will become divided. That is why it became half. Okay. So this is the end of question number 4. And now question number 5, let me read the question. After that, I will see whether it is necessary to solve or not. In question number 4, C is called a midpoint of a line segment AB. Prove that every line segment has one and only one midpoint. So this you can do it yourself, because this question is also from the question number 4 only. They just asked from question number 4 only. The question what they ask is, they ask every line segment they have only one midpoint. You just have to prove it, that one, by explanation. And it is very easy, because you know that in every line there is only one midpoint. Suppose if this is midpoint, then when you will put another point here, it will not become the midpoint. Or if you will write this side also, it will not be midpoint. So midpoint will be always in the center. So that is why this is the midpoint. So you will be explaining this one. Now question number 6, I will solve it. Okay. Okay, question number 6. Let me draw the diagram first. Diagram is, this is A, this is G. Here it is B, here it is C. So let us write first what is given, then we will see. Okay. Given is AC equals to BD. This one, AC from here to here equals to BD, means from here to here. Again, to prove means what we are going to prove, that is AB and CD. AB equals to CD, only this one, AB equals to CD. That means this middle one is not included here. It is not included means excluded. So you need to eliminate this middle part. You have to subtract it. So what you will do is, in your proof now, so proof always you need to start from the given. So given you write first, that is AC equals to BD. Now in the next step what you will do is, AC minus this middle part, BC is not in the answer, so that part you have to remove it. BC equals to again BD minus BC. See, before already I told you, read the exam and postulate. So if you will read there, you will be able to know why we are subtracting this one. Because there is one exam, that is, when equal are subtracted from the equal, then the remainder is always equal. There is one exam like this, so we are using same exam. These two are already equal given, and from the equal we are subtracting equal. See, this and this, same thing we are subtracting from both sides. Then the remainder also will come equal. So what we will get now is, now you look at this line AC. I will just explain here. Suppose this is A, this is C, this. See, this line is AC. So from AC, if you will subtract BC like this, then what it is remain there? It is remain only AB. So when you subtract this, you will get AB. Then similarly in the right side again, you look at BD now. BD, and here it is C. Now from BD you have to subtract BC now. Subtract BC. This part you subtract. Subtract the BC and you tell me now what is remain. It is remain CD. So when you subtract this one, it will remain CD. So this is the answer. In this way you will be doing. Now question number 7. Why is exam number 5 in the list of Euclid exam considered as universal truth? So why exam 5 is universal truth? We have to just give the reason. So let me see what is in exam number 5. Okay, exam 5 is the whole is greater than a part. The whole is greater than any part. So I will just explain. You need to write yourself. Okay. Question number 7. I will just explain here. Question 7. See, this is a whole. You just think that this is our arc. Okay. Then now you divide into two parts. Either they are equal or unequal. So suppose this is center. So I will just divide it like this. So this is part 1. This is part 2. So you look at now, part 2 is very small as compared to part 1. But you know that this whole is greater than part 1 also, and the whole is greater than part 2 also. That is why always the whole is greater than any part of that same content. So that is why this statement is related to the universal truth, because your question is talking about the whole. About the whole means about the complete given value, whatever may be. That is why it is related to the universal truth. So you just need to explain in one statement or two statements and you have to write. Actually there is no any calculation. This is just I am showing you, but you have to explain in statement. In means you have to explain and you have to write in